Alright, in today's lesson we are going to continue learning about how to solve the quadratic. We're not really going to do that today, but we are going to focus on learning what makes a quadratic an irrational solution, rational solution, or have no solutions. First, it will be important for us to understand how to simplify radicals, so let's just go over this. So if I want to simplify 108, I'm going to think about what perfect square number can go into that. So these are numbers like 9 times 9, which is 81. That doesn't work. 7 times 7 is 49. Let's try 25. I'm just trying random perfect square numbers. 36. Ooh, 36 works. So my perfect square is 36, and 36 times 5 would give me that 108. And the square root of 36 is 6. And leave the square root of 5 alone. Alrighty. Now what happens when I want to simplify a square root symbol that has a number in front? I'm just going to leave that number in front and simplify the square root into a perfect square and a non-perfect square. So let's try 54 divided by 49. Doesn't work. 54 divided by 36. No good. 25. No good. 16. No good. 4. No good. 9. 9 and 6. Perfect. And the square root of 9 is 3. Square root of 6. 3 times 3 is 6. And leave the square root of 6 alone. Good. Alright, let's try this next one. Now, whenever you want to add or subtract square roots, they have to have the same number under the radical, kind of like making it a like term. So I know square root of 6 cannot simplify anymore. But I can simplify the square root of 24 into 4 is the perfect square and 6 is not the perfect square. The square root of 4 is equal to 2. Leave square root of 6 alone. And then 2 times 2 is 4, square root of 6. 2 minus 4 is negative 2, square root of 6. And let's try this last one. Whenever you're multiplying or dividing radicals, you can do it by just doing the outside numbers. Negative 4 times 1 is negative 4. And then inside the radicals, 8 times 10 is 80. And now we can simplify that. 80 simplifies into 16 and 5. Because 16 times 5 is 80, and 16 is the biggest perfect square number that works. Negative 4 times 4 is negative 16, square root of 5. Nice job. Alrighty, for today's lesson, we're not going to do any of this simplifying, but we will in tomorrow's lesson, so it's important for us to know how to do it. Alright, so today we are going to learn how to determine the nature of roots. Remember, other names for roots are solutions, or zeros, or x-intercepts. And we're going to find out, will there be 1, 2, or no roots? Alright, so the standard form of a quadratic equation is ax squared plus bx plus c, and it has to equal 0. Once we could get it to equal to 0, that's where we're able to find the real number that is a, b, and c. A will always have to be something bigger than 0, something not equal to 0, because we want to have an x squared in our problem. So let's look at the first one. In order for me to say what my a, b, and c is, I need to get this equation equal to 0. So I'm going to add 2 to both sides, and that will leave me with 4x squared plus 3x plus 2 equals 0. And now let's see, the number in front of x squared is 4, in front of x is 3, and our constant is 2. In this next one, I want to get rid of this 1x. By subtracting it, I'm going to put it with the other x. So that would give me x squared minus 3x plus 7 equals 0. So then a is 1, b is negative 3, and c is 7. And in this last one, I want to get rid of this 3x squared, so I'm going to subtract 3x squared. And this will leave me with negative 3x squared minus x plus 9 equals 0. So a is negative 3, b is the number in front of x, which is negative 1, and c is 9. Alright, nice job. So today we are going to use what a, b, and c equals to calculate what b squared minus 4ac equals. When we find this number, we call this number our discriminant. if we end up getting a number that is 0, that will mean that our quadratic equation just crosses the x-axis or touches it once, meaning that we'll have one real root, and because it's only one number, that one number is equal to ourselves. So we can say that it's one real root that's equal. Then if we have a number that is bigger than 0, if our discriminant is bigger than 0, we'll say we have two real roots. That means there's two places where it touches the x-axis, and these are going to be unequal roots because two numbers can't be equal to each other unless they were the same number, but then that would just be one real root. Now, if we have a number that's less than 0, we will say there is no roots. That means it never touches the x-axis. So, no real roots. And then one more thing is we can tell, is it a rational or is it an irrational answer by, once we find that discriminant, if when you take a square root it would be a perfect number, that would be a rational root. If it would end up with that big ugly decimal, that would be an irrational number. Alright, so let's get into this. Alright, first we're going to say what our A, B, and C is, find the discriminant, and then talk about the solutions. In order to do this, we need to get this equation equal to 0. So we would have x squared minus 6x plus 10 equals 0. So A is 1, B is negative 6, and C is 10. Your discriminant formula is b squared minus 4ac. So b here is negative 6, make sure you put it in parentheses, minus 4, a is 1, and c is 10. And let's type this in the calculator. Parentheses negative 6 squared minus 4, parentheses 1, parentheses 10. And that equals negative 4. Because this is a negative number, that means there is no real roots. And why is that? Because if you tried to take the square root of this number, negative 4, it would be an error, non-real answer, so no real roots. Alright, let's look at this next one. I want to find what A, B, and C is, so I'm going to have to start by getting this equation equal to 0. So I'm going to subtract 1 from both sides. Those are not like terms, so I'm just going to write 5n squared minus 1 equals 0. A is the number in front of the squared term, so that would be 5. B is the number in front of the plain variable, which we don't have that here, so that would be 0. And C is negative 1. Our discriminant formula is b squared minus 4ac. So b is 0, so 0 squared minus 4. A is 5, and C is negative 1. And let's type this in the calculator. 0 squared minus 4, 5, negative 1. And that gives us 20. So, because the number is greater than 0, that means we have two unequal roots. And I want to know, are these rational or irrational? So let's see, what is the square root of 20? The square root of 20 is a irrational number. So, two unequal irrational roots. Nice job. Alright, let's go look at this next one. Let's get this equal to 0, so I'm going to add 1m to both sides. I'll add it with the m term. So that will give me 7m squared plus 2m minus 4 equals 0. So A is 7, B is 2, and C is negative 4. Discriminant formula is b squared minus 4ac. B is 2, so 2 squared minus 4. A is 7, and C is negative 4. And let's type this in the calculator. 2 squared minus 4, 7, negative 4. And we will end up with 116. Because that number is bigger than 0, that would mean two unequal. Now let's determine if this is rational or irrational. If I take the square root of 116, that would be irrational. So two unequal irrational roots. It's two of them because the number is bigger than 0. It's unequal because if I have two numbers, they're not going to be equal to each other. And it's irrational because if I try to take the square root of that number, that's an irrational number. Alright, let's try this next one. Let's add this 2s to both sides. So I would get 6s squared. Negative 2s plus 2s is 0. Plus 5 equals 0. The number in front of the s squared is 6. Number in front of the s is 0 because there's no s. And then our constant is 5. Discriminant formula is b squared minus 4ac. B is 0, so 0 squared minus 4. A is 6, and C is 5. Let's type this in the calculator. 0 squared minus 4, 6, 5. And that gives us negative 120. As soon as you see a negative number, that means no real roots, because you cannot take the square root of a negative number. Alright, you do. I want you to pause this video and try this. See how you can do it. A is negative 9, B is 10, C is 6. B squared minus 4AC. B is 10, so 10 squared minus 4. A is negative 9, and C is 6. So 10 squared minus 4 times negative 9 times 6. Let me type this in real quick. 10 squared minus 4. B squared minus 4A is negative 9. C is 6. I don't know why. I just feel like I typed it wrong. Nope. The discriminant is 316, which means it has 2 unequal solutions. And even further, let's see, is 316 a perfect square? It is not, so 2 unequal irrational solutions. Alright, let's try the next one. We need to get this equal to 0, so I'm going to subtract 2y. I would get negative 4y squared minus 5y equals 0. So A is negative 4, B is negative 5, and C is 0 since there's no constant. Discriminant formula is b squared minus 4ac. B here is negative 5 squared, make sure you put in parentheses, minus 4. A is negative 4, and C is 0. So let's see, we get negative 5 squared minus 4 times negative 4 times 0. And we get 25. So the discriminant is 25. Therefore, there is 2 unequal solutions. And what is the square root of 25? The square root of 25 is 5, which is a rational number. Alright. Very, very nice. Alright. Now, which graph represents a quadratic function with a negative discriminant? If I have a negative discriminant, that would mean I would have 0 solutions, meaning it would never cross the x-axis. And that is answer choice 4 right here. This one touches twice, touches once, but this one never ever touches. Good job. Alright. Let's see this one. If 0 is the value of the discriminant, when I have 0 as my discriminant, that means I have 1 solution. Which graph is here? Well, it's not going to be this one. It's not going to be the sideways one, because the standard form equation doesn't look sideways. This one crosses no times, which is not going to be the case. This one touches twice, not the answer. It is answer choice 2, which only touches 1 time. Let's look at this next one. Which statement must be true if it does not intersect the x-axis? If it does not intersect, that means our discriminant is 0. No, not 0. If the discriminant is 0, that would mean there was 1 solution. For it to never touch it, then we would need 0 solutions, and the only way you get 0 solutions is if you have a negative discriminant, which is answer choice 2. Alright, if the roots of this is real, so real means the number needs to be greater than 0 or equal to 0. Rational, which means it needs to be a perfect square. And if it's equal, that means there's 1 solution. And you only get 1 solution by having the number equal to 0. So let's see. It intersects it at 2 points? No, because we want to have 1 answer. It lies entirely below or above? No, that would mean there's no answers. Or it's tangent, which means that it touches it once. That sounds true. Let's look at this next region's problems. The root of a quadratic equation is real. So real means equal to 0 or greater than 0. So it's not going to be choice 4. Irrational means it needs to be a number that the square root of it would be irrational. Well, the square root of 1 is 1, square root of 0 is 0, and the square root of 8 is a decimal. So it would have to be choice 3. And also because it's unequal, that means the number has to be greater than 0, so it couldn't be 2. And then it's not 1 because the square root of 1 is a rational number. Alright, try this one. Pause this video. The roots of a quadratic equation is real, which means it's either equal to 0 or greater than 0. So not choice 1. Rational, which means if you took the square root of it, it would give you a perfect number. That's either 0 or 4. And equal, if it's equal, that means there's only one answer, which would have to be one that is equal to 0. So choice 3. And let's do this little flashback from the past. For which value of P and W is P plus W a rational number? Alright, let's look at the first one. Well, I know for it to be a rational, I need to have a perfect square. So these are numbers like 1, 4, 9, 16. Which, the only one that I see that is choice 2. And let's just double check that this is true. If I added these two numbers, would they be perfect square? Would it be a perfect number that is rational? 1 over 4 plus 1 square root of 9. Yep, that is a decimal that repeats, making it a rational number. And let's try this one. Which one represents an irrational number? Alright. Well, I know anytime I add fractions together, it's going to continue being a fraction, so that would not be an irrational number. 2. Let me try typing this in the calculator because I'm unsure about this. 1/2 plus the square root of 2. Ooh, that's big, long, messy. That's irrational, so it should have choice 2 in it. So not 2. And not 3. Okay, let's see the next one. The square root of 5 times the square root of 5. Oh, that gives me a rational number, so it's not going to be 3, which means it can't be 4, which means my answer has to be 1. Alright, and that is how we find the discriminant and how we use the discriminant to tell us stuff about the quadratic.